Good morning, students. I send you electrodischarge machining process, or it is called EDM process. Okay, it is a non-conventional machining process. What is non-conventional machining process? These are different from the traditional machining processes, such as lathe, milling, shaper, drilling, grinding. You know all these machining processes. Okay, and the non-conventional machining processes is that if any material is very hard and tough, which cannot be machined in a traditional way or traditional machining process, or cannot be cut in a traditional machine, then we use non-conventional machining processes. Okay, the electrodischarge machining processes is one of them. Okay, here see, we need DC power supply or a DC power supply generator which have 0.5 to 400 ampere current, 40 to 300 volt voltage. One tool holding electrode which is made of copper, tungsten and graphite alloy. Okay, and the shape of the electrode or tool is same as the part desired. Which type of workpiece we require, the tool is desired at that type. Okay, then a servo mechanism or drive unit to control the movement of the electrode to maintain the correct distance between the workpiece and the tool feed mechanism, and a coolant. It is normally a dielectric or a light mineral oil that forms dielectric with non-conducting. That means electric current cannot pass through it. Non-conducting barrier between the electrode and the work gap. Okay. What is the process electrodischarge machining? Electrodischarge machining is also known as spark erosion, electroerosion machining process. Here in this diagram, see the workpiece fixed with the fixture. Here a tank in which dielectric is filled. Dielectric, here a pump and a filter, because it is recycle. If any bars or any metals are mixed with the dielectric, then the pump is filtered here, then it is recycled again. And here the tool, this is negative, this is positive. See, this is the DC pulse generator. The tool is fixed in the negative terminal and the workpiece is fixed in the positive terminal. And here a servo control unit is added, which feed the tool to maintain the work and tool gap. And the gap is how about 0.025 mm. Very little gap. If gap is more, then spark is not created. So gap is very little. Okay. When we start the DC pulse generator, okay, the voltage across the gap reaches, and the cause the dielectric to break down. If the dielectric break down, here the spark is created. And the spark temperatures around 10,000 degrees centigrade and pressures many thousand times greater than atmospheric are created. Okay, and each spark is created in less than 1 microsecond, and each spark erodes a minute piece of metal from the workpiece. Okay, but it is very less, minute piece is very less, but the sparking occurs 20,000 to 30,000 times per second, so the metal is removed easily. Okay, so appreciable, or how much metal we require to remove, it is easily removed. See, I send you the advantages and disadvantages also. Okay. You study and question me if you have any doubt. Okay, thank you. Bye.